This is an example solution for one of the questions from the pressure synthesis problem set from scienceprimer.com. I pulled this question right off the website. When the page loaded, this is the question I got. Calculate the pressure required to raise a 0.7 square centimeter column of water 3.5 meters high on a planet where gravity is 9.4 meters per second squared. We're asked to provide the answer to the nearest tenth of a kilopascal. Let's start first by describing the experimental setup. Talking about a situation where we have some kind of a container where there's pressure pushing on water such that it's raising a column of water to a height of 3.5 meters. And this column of water has a cross-sectional area of 0.7 square centimeters. So these are the two of the pieces of information we're given. We know the height of the water and the area. We're also told that gravity equals 9.4 meters per second squared. So from there, we want to find pressure in kilopascals. Now it's useful to mess around with these units a bit to understand what we're looking for. 1 kilopascal equals 1,000 pascals. And 1 pascal is equal to 1 Newton per square meter. Looking at it this way reminds us that pressure is a force acting over an area. So that's what we're looking for. We're looking for a force acting over an area. Newtons over square meters, which we can convert to pascals. Knowing this, we can work backwards from this goal to figure out how we can use what we know to find this. So pressure equals a force holding the water up over the area. And we already have area, so we already have part of the answer. Since no motion is described in the question, we can assume that the pressure up, holding the water up, is equal to the force pulling down on the water. The force pulling down on the water is the weight of the water. The weight of the water is its mass times acceleration due to gravity, and we know acceleration due to gravity. So if we can find mass, we can do that, and we can find mass from the volume of the water, knowing that the density of water equals 1 gram per cubic centimeter. So we find volume, use that to find mass, and from mass we can back all the way up to pressure. So the first step, find the volume. And the volume is going to be the height in centimeters times the area, which is already in square centimeters. So 3.5 meters, convert this to centimeters, multiply by the area in square centimeters, we end up with 245 cubic centimeters. Convert that to mass by using the density. So volume times density equals mass. 2.45 cubic centimeters, 1 gram per cubic centimeter. The same number, but to get to newtons we need to go to kilograms. So we'll convert this to kilograms. And we end up with 0.245 kilograms for the mass. We can use the mass to find the weight. So it's mass times gravity. So 0.245 kilograms times 9.4 meters per second squared. 2.3 kilogram meters per second, which is equal to 2.3 newtons. And the final step is if we divide the weight by the area in meters squared, we'll get the answer. So to go to meters squared, we take the 7 cubic centimeters, divide by 10,000 to convert to meters squared. we end up with 7 times 10 to the minus 5 meters squared. Use this, and we end up with 32,857 pascals. Divide by 1,000 pascals to get kilopascals, and our answer is 32.9 kilopascals. We can come back over to the website and enter 32.9, submit the answer, and we'll get the feedback that that is correct. With a gravity of 9.4 meters per second squared, the pressure required to raise 0.7 cubic centimeter column of water 3.5 meters is 32.9 kilopascals.